Hi JT, here's my video explaining my water resources final. So for the first problem, here's all the parameters. And this part, section A, had I equals 0, so there's no correction value that I had to do. So first you find the S with the curve number, that's all you need, so I plug the curve number in. Then once you find the S, you can find TL using the formula. 0.5 is the percentage. You gotta leave it like that. I got this hours. Didn't have to do any correction value for the time. So the peak time, half and 30 minutes, so that's 0.5 plus the TL for the hours, and then QP, we kept this in kilometers squared, and this we left in hours to get 1.41 meters cubed per second. So then here's my hydrograph. The QP, the QP is 1.41, TP is 5.16, and then we can find TB, multiplying the TP by 2.67 to get 13.78. So we can find the area, 1/2 the base times the height times 3,600 to convert it to seconds. And we get this, and then we can verify that it's 1 centimeter by putting the area over the original catchment area, and that verifies to 1 centimeter. So for the second part, the only thing different is the curve number and the I value. So we can find the S by plugging in the curve number, and then once we get S, we can find the TL using the same equation. And then since I is equal to 45%, we have to do a correction factor. So here's all my values plugged in. You got to plug in the curve numbers, and my correction value is 0.685. Multiply the correction value by TL to get TL corrected. And then TP, same time, it's a half hour, and this time use the corrected time to get 1.6 hours. And QP, use TP, and then you keep this in kilometers squared. Here's the hydrograph. QP is 4.55, TP is 1.6, and then TB is 1.6 times 2.67. The area is 1/2 base times the height, and then you got to convert it to seconds to get this, and then you put the area over the original area, which is 3.5 kilometers, and that verifies that it's 1 centimeter. For the next problem, we had to find total infiltration, and total rainfall. The infiltration rate was 1.1 inch per hour. So just to get, and the time is in half hours. So to get the total rainfall, it's just the intensities times the time. They're all in a half hour, so you sum these and then multiply it by 0.5 to get the total rainfall. And then to get the runoff, you get the intensities, which I just took from up here. And then the infiltration rate is 1.1, so you subtract the intensity by 1.1, and if it's less than 0, you just write it as 0. So then the rainfall excess, you would multiply this value by the time, which is half an hour, so you multiply it by 0.5. You get these values, you sum them together to get 1.15 inches of runoff. And then to get the total infiltration, it's just the total rainfall minus the runoff. So the total infiltration is 2.7 inches. And the next problem, so this one was to find the slope. And to find the slope, you need a point before and after the peak. So the point after the inflection point was 1200, 7, and the other one was 500, 2. So it's y2 minus y1 over x2 minus x1 to get the slope. And then here's my base flow. This is the slope times the time difference plus the intercept, which was 500, to get 780. And then I didn't get part C. And then for question 5 was the Excel problem. For this problem, I used constant slope method. I found all my DQ values. From there, I found my slope. And from there, I was able to get, well, I also found the inflection point, which is right. That's the turning point, so the inflection point's right here, the one right after. I was able to calculate the slope. And this is the final direct runoff hydrograph using the constant slope method.